Hello and welcome to the class. So today in this class we are going to discuss about the tachogenerators. Okay, so simply if you want to understand that what is tachogenerator simply converts the rotational speed. Okay, it simply converts the rotational speed into the proportional voltage. It can be a AC voltage or it can be a DC voltage. Okay, it can be both. So let's discuss about both type of generators. So tachogenerators are of both types, that is it can be AC or it can be DC. Okay, so first of all we are going to discuss about the DC tachogenerators. DC tachogenerators. All right, so let's draw the first of all the simple diagram. So this is a simple diagram of DC tachogenerator, in which these are the magnets, the permanent magnets we are using north south, and this is the you can say armature in the DC motor or the DC generator. You know that where is the armature? Armature is on the rotor, so this is the armature. So this is the, since the generator is there, the armature producing the voltage E. This is the output voltage E we are getting by using this generator. Okay, omega is simply the speed, the input speed which we are giving to this generator. By using this speed rotating the generator, we are getting the output. Okay, so as I already told you, the DC tachogenerator is simply what it converts. It converts a rotational speed, okay, into proportional DC voltage, into proportional DC voltage. All right, so first thing is this. Second thing, it uses permanent magnet for producing magnetic field. So there must be the magnets which used in the magnetic field. So it uses permanent magnet. It uses permanent magnet to produce magnetic field. All right, now as you can see in the figure, since our tachogenerator is coupled to the shaft, tachogenerator is coupled to the shaft, okay, so the speed is to be measured. Okay, since you know that the magnetic flux is constant. Magnetic flux, since we are using the permanent magnet, so magnetic flux of the generator should be constant. Okay, so the induced voltage at the terminal, the induced voltage at this terminal, the induced voltage at this terminal is simply proportional to the shaft speed, and the polarity depends simply upon the direction of the rotation. So what is this? Induced voltage at the terminal of armature is proportional to what? Is proportional to shaft speed, and the polarity depends on direction of rotation, and polarity depends on direction of rotation. All right, so what we got? E should be directly proportional to omega. Omega is the rotational speed. E is simply the voltage at the terminal. So this will give you E should be equals to K TG, tachogenerator constant, okay, omega. Okay, where KTG is simply a tachogenerator constant, which can be expressed in KTG is expressed in voltage per radian per second. Okay, so just let's take a Laplace transform of the above equation. Laplace transform of above equation it will give you simply what? Es, which is equals to k Tg omega s. Alright. So in the block diagram form, if you want to draw it, you just simply got what? KTG. Okay. This should be omega s. Okay. And this should be what? Es. Alright. I think I have just write down the things in the reverse direction. Sorry, this is Es, that is output upon the input. Okay, we are getting the output since the tachogenerator. We are getting the output at the terminal voltage Es, and omega s simply what? Omega s simply your speed. Okay, so the output upon input is simply the transfer function. Es upon omega s. This will give you what? KTG. So this is simply the transfer function of the tachogenerator, which is relating the output. Output is what? That is your ES, the voltage at the terminal, upon the input, which is what? Your rotational speed. Okay. So up to here. So this is about the DC tachogenerator. Okay. Now let's move further and let's discuss about the AC tachogenerator. AC tachogenerator. Now AC tachogenerator is simply what? AC tachogenerator is used to convert rotational speed, into proportional AC voltage, and this simply works on the principle of induction motor. Works on the principle of induction generator. All right. So simply the simple diagram of the AC tachogenerator is shown over here, and since we have already told you that it works on the principle of induction generator, so in the single phase induction generator, or you can say the two phase induction generator, since it is not there must be two windings. So this is the main winding, that is the output winding. As it is a generator, it will give the output on this side, and this is the rotor, okay, which is connected to the shaft, and this is the reference winding. Okay, when this shaft is going to rotate with the angular speed of omega, it will give you the output voltage E at the output winding. Okay, so the tachogenerator is simply coupled to the shaft, of which speed is to be measured. Okay, so the reference winding is simply supplied by the reference voltage. Okay, reference winding, it is supplied by the reference voltage. Okay, and the output voltage E is induced across the output winding. Okay, so the amplitude and the phase of the output voltage is simply the amplitude and phase of the output voltage depends on the direction of rotation. Depends on direction of rotation. All right. So simply we can see that the output voltage E is related to shaft speed. Okay. So we can write in a very simple manner, E should be directly proportional to omega. E is equals to KTG omega, where KTG is simply the constant, and the Laplace transform of above equation, the Laplace of above equation can be written as ES is equals to KTG omega S. Okay, in the block diagram form we can very easily draw this KTG and this is the output is what, simply your es, and this is the input is what, your omega s. Okay, output upon input is giving you simply the ktg over here. Okay, you can write down this also, that is e as the transfer function of the AC tachogenerator is simply what, es upon omega s is equals to ktg. Okay, so this is simply about the AC tachogenerator. Okay, so in this lecture we have discussed about the tachogenerator, both the DC tachogenerator and the AC tachogenerator. Thank you, thanks a lot.